All right, so tonight what we want to do, continuing with our linear theme for this unit, we want to spend a little more time talking about slope. All right, slope is something that we did talk about last night when we were graphing the equations of lines, and slope was, rise over run. This is something that a lot of you have heard for a while now. Rise over run. Slope, the top number always tells us on the graph, whether we're going up or down, and then what we're going over to the right, and then positive means we're going up and negative means we're going down, and we've done rise over run. We had equations last night, and we said that in the equations, y equals mx plus b, that the slope is that number in front of x. And when we had a graph last night, you guys had to write the equation, and we could count on the graph our rise and our run to find the slope. But sometimes we just have 2 points, and we want to be able to find the slope. And so I did want to go back, and I wanted to review the slope formula. All right, so the slope formula. If you have 2 points, you can find slope by using this formula, and you may have seen it before. M is the slope, and it is equal to y2 minus y1 over x2 minus x1, and that's if we have 2 points, x1, y1, and x2, y2. Now, a lot of students see this formula and they get a little confused because of all the subscripts, the tiny little numbers down at the bottom, and they just like, whoo, that went over my head, Miss Parker. What you want to realize is all these subscripts are telling you is that these are 2 different points. This x and this y go with 1 point, and this x and this y go with a second point. So you're not multiplying anything by those 1s, you're not adding those 2's to anything, you're not multiplying those 2's times anything. It just shows that this is the y that goes with this x, and that this is the y that goes with this x. They go together. In fact, it doesn't actually even matter which one comes first. What's important when you're finding slope in the slope formula is that this y and x go together, and that this y and x go together. It's also important that this is always subtraction, because we're going to subtract. So if this is a negative number, I am subtracting a negative. So that's going to always end up, minus a negative is plus a positive. So we do need to be very careful with signs. But for example, if I have the 2 points, negative 5, 3, and 1, negative 7, 1, negative 7. So I've got these 2 points. If I want to find the slope, what I have to do is I need to remember that the y's go on the top and the x's go on the bottom. And I want to make sure that this x and y, the x on the bottom and the y on the top, come from the same point, and that this x and y come from the same point. So when I am doing my slope formula, I do something to help me be careful. I want to make sure that my points stay together. So what I do is I take the first point and I put it in the formula first. Y goes on the top and x goes on the bottom. Then I take my second point. I put y on the top and I put x on the bottom. And then I put in my subtraction signs. This way I don't make a mistake and leave anything out. And so when I'm actually doing my math here, I'm going to get minus a negative 7, which is going to become plus a positive. So 3 plus 7 is going to be equal to 10. And then when I do negative 5 minus 1, negative 5 minus 1 is negative 6. And so a positive divided by a negative is a negative. 10/6 is a fraction, but we said slope, we kind of expect it to be a fraction. It's rise over run. But I do need to reduce it. So these will both reduce by 2. So this is going to be 5/3. So negative 5/3 is the slope between those 2 points. And so just remember, these 2 have to be from the same point, y on the top, x on the bottom. These 2 have to be from the same point, y on the top, x on the bottom. Don't forget x is always what comes first and y is what comes second. And then this is our slope formula, and we can find the slope between any 2 points. Something else that I want to talk about with slope is a little more about just application-wise. What is slope? We said it was rise over run. When you look at the formula, we're subtracting the y's and we're subtracting the x's. In science, we have a way of showing that with a delta. I know it looks like a little triangle, but it is actually a Greek letter, delta. Delta y and delta x. In science, this lovely little delta here, and we use it in math too, but science and math, the little triangle, delta, it's a Greek letter, delta, means change in. So when you subtract two numbers, you're finding the difference between them. You're finding the change. So this is the change in y over the change in x. How did something change? So what slope is, generally, you know, we talked about the x, the ultimate independent variable, is usually time if we think about it. We're looking for the change in y over time, distance over time, rate is what we're looking at, per. Slope is a rate of change. How is this changing? We actually talked about this with the story graphs that we did last unit. We talked about if something had a straight line, that was its slope. That meant it had a constant rate of change. That's why it's a straight line. The slope is that constant rate of change. When we had a curved line, that meant that its rate of change was changing. It wasn't staying a straight, constant slope. It's got a changing slope. That's why it's not a straight line. So slope is a rate of change. Key word when you're reading a problem or you're talking about a situation for a rate of change is per. That's what we tend to use in the English language for it. If I'm talking about my car, it has a rate of change. It's called miles per hour. Miles per hour. Our health, we talk about our heart rate. Your heart rate is in beats per minute. When we talk about rates, interest rates, you know, 2.8% per year. It's an annual percentage rate per. So when we talk about rates, you almost always see the word per somewhere because we're talking about a rate of change, something per something. And that's what this is, the something per something. Miles, that's why the y variable is the miles. Per hour, time is the x variable, so miles per hour. This lovely little division bar here is basically the per, okay? So slope is a rate of change. This is handy when we start trying to do word problems and we're trying to figure out how can I write my equation. Something else that we talked about when we did our story graphs was that on our story graphs, the y-intercept, we said that that y-intercept, because x was usually time, and time starts at 0, we don't usually talk about negative time and stuff like that, our y-intercept was always our starting point. So our y-intercept is always our starting point, and our slope is always our rate of change. If you think about it that way, we know slope is the m, and the y-intercept is the b. If you're reading a word problem, and you notice that it starts somewhere, and that it has a rate of change, it's got something with per in it, those are the two numbers we need to write an equation. Y equals mx plus b. I know what my m is going to be because it's going to be the per in the problem. The miles per hour, the beats per minute, he makes $10 per hour. When you've got that per, now sometimes they'll try to throw you off and say, for every, you know, he makes $7 for every hour he works, or she makes $30 for every basket she sells. You know, so per, for every, those are kind of things that you will see in word problems when they're talking about a rate. If I'm making $10 for every basket that I make, I'm making $10 per basket. If you can reword the problem so that it has per there, whatever the per is the slope. Where you're starting, that's going to always be your y-intercept. So what does that look like in some word problems? So let's take a look at a couple of examples. So I've got this particular word problem. It says the cost of a school banquet is $95 plus $15 for each person attending. Write an equation that gives the total cost, okay? So the total cost as a function of the number of people attending. So when I look at this, the first thing that stands out to me is I make $15 for each person. So I'm making $15 per person. $15 per person. That means that this is my slope. It's got the per. All right? So if I know that a linear equation is y equals mx plus b, I know that I'm making $15 per person. That means that the money is my y, because slope is always the y over the x. So if it's $15 per person, the dollars go on top, and the number of people, the persons, go on the bottom. So that means x is the number of people, and y is the money, the cost. So they wanted it as a cost for the number of people attending. So I could make C be the total cost, and P be the number of people attending. Those will be the persons, okay? So that would mean that C equals mx plus b. So we just said that the slope has to be 15. So C equals 15p, because x was the number of people, y was the dollars. B is the y-intercept, though. We said it was a starting point. So a starting point is basically where there's 0 people. Well, notice that they said that the cost of the school banquet is $95 plus $15 for each person attending. This is a starting value. You'll find this in a lot of things. If you need to have work done at your house, when people come over, they charge you a flat rate just for showing up. And then they charge you per hour on top of that. You'll see that a lot in things. And so this is our starting value. With nobody coming, we're at least going to have to pay $95. And then $15 for every person that does come. So this is our starting point. That's our y-intercept. Per, slope, starting point, y-intercept. So this is the equation for that situation. Now, what is the cost for 77 people? Well, all I have to do is actually plug 77 into the problem in the correct place. Now, do be careful. Sometimes they'll try to trick you, and instead of giving you the number of people, they could have said, well, what is it for, or how many people would cost a certain amount? You know, so you want to make sure that you're reading the question correctly. But this one did say people, and so that means that I can just plug it in for people. So when I do 15 times 77 plus 95, I get 1,250. 1,250, but I always want to remember my units of measure. Our cost was in dollars, and so I will put the dollar sign right there. So $1,250. We can do this for any type of situation. For example, if we look at question number 2, it says in 1980, the average price of a home in Brainerd County was $97,000. By 1986, the average price was $109,000. All right. We're going to hold off on this one until next week, because this one, they didn't give us a starting point per se at 0. They give us 2 points. And we are going to talk about next week, how do we write these equations? How do we write the equation of a line when I have 2 points and one of them is not the y-intercept? So we will work on that one next week as a class. Let's see. So here we have a sunflower in Julia Rosario's garden was 12 centimeters tall when it was first planted. So first planted, that is definitely a starting point. So when it started, it was 12 centimeters. That means this is going to be my B. Since then, it has grown approximately 0.6 centimeters per. See, this one even used the word per day. That's the per, that's my slope. So that means that I'm going to need to do y equals 0.6x plus 12. Now, do notice that they wanted h to be the height and d to be the number of days. So I need to figure out which one is x and which one is y. So don't forget your per. If it's centimeters per day, the top is always y and the bottom is always x. So that means that x must be my number of days, so that's going to become d. And then y was the top in centimeters, so that must have been the height. So h equals 0.6d plus 12. And that gives me the equation for that particular situation. Where did it start? That's my y-intercept. What is its rate? Slope is a rate.